So this is our wave function on which we will do our calculation. We know about the A naught, that this A naught is the Bohr radius, which we have converted this E square over 4 pi epsilon naught 1 over A naught is equal to minus 2 times the E1. This we have used in earlier calculation, so we will have to do this thing as well. But there will be one change here, and that change, let me note that this is E square over 4 pi epsilon naught, so this E square will become Z times E square. This one change we will have to do. Then it will be, this will become, this is A naught, and then when it is E square for this, so Z E square. So we will have that A equals to the A that we will utilize will be A naught over Z here, because one it will become this due to the reason that E square will then go to Z times E square. As we have introduced Z, so we will again and again incorporate this thing in here. Now let's do calculate 1 over R 1s here. So this thing is equal, the two wave function when multiplied, then this will come out to be z cube over 8 pi z cube or pi a cube. No 8 here, z cube or pi a naught here. Okay, so I will have to write this a naught, then integral from 0 to infinity and e to the power, because I will have to write this, 2z and r over a naught. Now we will have to think on this thing, that this will be psi 10 multiplied with psi 10, this is minus zr this, so it will be just a simple square of this thing. So we will have the simple square will become minus 2zr over a naught, and 1 over r will come in here from the expectation value, and then it will be d cube r. So d cube r I will write for this is r squared dr and sine theta d theta and d phi. Now I have written this integral from 0 to infinity for r, not for this one. So for this I will write 0 to pi, and for pi I will write 0 to 2 pi, and I know that this will only contribute a solid angle 4 pi to the equation. So 4 pi here from this, and we have 4 pi, this thing equal to 4 pi, and then z cube over pi a naught cube, and then integral 0 to infinity and e to the power minus 2zr over a naught, and 1r will simplify with this, so r dr. Now this integral is a simple integral, it is not a complex one, because r here and then e to the power this in dr, we know that for such an integral we have the formula that when we are having integral from 0 to infinity and x e to the power minus bx and dx, then this is equal to 1 over b squared. Now here, if I look to this one, then x is equal to r, because here x is equal to r and b is equal, b which is here minus minus, so x, so b is 2z over a naught, 2z over a naught, and 1 over b square, then this integral will come out to be 1 over b squared. So 1 over b squared I can write, this implies that 4 pi z cube over pi a naught cube, and this will come out to be 1 over b square, so it will come out to be a naught square over 4z squared, a naught square over 4z squared. And we can simplify this one. If I look here, then 4 pi is gone with 4 pi here, z square is gone with 1z will remain there, a naught square gone with 1 this, so we are left only with z over a naught. So this value comes in, the expectation value comes in to be equal to z over a naught, and VEE we have already calculated, so this implies that 1 over R1s equal z over a naught, and we have already calculated the VEE, and over there we will use the term which we have calculated equal to this. So for VEE equal 5 over 4a e square over 4 pi epsilon naught, we will have to use a basically goes now to 2a naught over z, because we have to do this conversion, and after this conversion the VEE will come out to be, this implies that VEE, the electron repulsion term, will then, after the introduction of this A equals to 2a naught over z, we have 5z over 8 a naught and e square over 4 pi epsilon naught. And now we will have to, we have found h naught already, we have found h1, we found that it comes out to be here 2z minus 2 e square over 4 pi epsilon naught, and this value came out to be z over a naught. So there will be simplification and we will write everything together. So by putting everything together, we have this thing equal to, and we will also utilize this thing here, that e square over 4 pi epsilon naught 1 over a naught is minus 2e1. So we will convert everything in terms of e1. So h comes out to be equal to 2z(e1), we have 2z square e1 here, 2z square e1, and then we will write the things in terms of e1. Then This will be 2 times z minus 2 and e square over 4 pi epsilon naught, and what of 1 over r we are having z over a naught. So this is z over a naught and e square over this plus 5 the VEE term 5z over 8 a naught and e square over 4 pi epsilon naught. So we have written this thing, and now we will go for converting the things into E1. If I look here, then this thing is equal to E1, and similarly this thing is equal to E1. So for this I will write minus 2 E1. This is equal to minus 2 E1, and for this I will write minus 2 E1. So our final expression will become H equals 2 E1 z squared plus 2 z into z minus 2, because 2z into z minus 2, and for this I will write minus 2e1 plus 5z over 8 and minus 2e1, and we have the things equal to this, and there is some simplification, and we will have to simplify the things now. So what will be simplification? 2e1 z squared, then this will become 2z squared here, this is 2, and then minus 2 is here, so it will become minus 4 times z, so minus 4ze z square e1, then minus 4 will be multiplied with minus 2, so it will become plus 8 times z and e1. Similarly here it will be 2 will cancel with this 4, so 5 over 4 with a minus z times e1. So this is very simple simplification we have, and this will become H is equal to E1. If I take E1 is common, then things will become, because E1 is here, E1 is here, and E1 is here, so it will be easy to do the things. 2z square is here, then minus 4z square, so minus 4z square, then minus 4 with minus 2 will become plus 8 and 1z will come. 8 and 1z will come with this, and then minus 5 over 4 and z. So our expression finally is this thing. And now here we are at the final stages, and we have got H in terms of Z, and we know one fact, that the fact is this one, that whatever you do calculate H, it will always be greater or equal to EGS. So it means if we do minimize this function with respect to Z, then this will give us the effective value of Z, because Z we have incorporated. Now Z is not equal to 2, as we know in the situation. So for this we will have to minimize this H, and if I do minimize this H, then I know that d over dz with respect to z, I minimize this will be equal to 0, and this implies, but before going to this one, why not to simplify this thing a little further? And look here, this is 2z square minus 4z square, so it will be minus 2z square. This is 8z and 5z, so 4, it will become 32z minus 5z, 27z. So this is plus 27z over 4. So this is our final H. And now we are going to minimize this thing H, because we do minimize this and yet it will be greater or equal to EGS, and this will help us in finding out the effective value of Z. So take the derivative of this with respect to Z and it will come out to be minus 4Z, because 2Z and then minus 2 will make it minus 4Z plus 27 over 4 into 1 is equal to 0, and this will make that z is equal, minus 4z is equal to minus 27 over 4, so minus minus cancel, and z equal 27 over 16. Z equals 27 over 16, and 27 over 16 basically gives us 1.69. So instead of z equal to 2, we reach z equal to 1.7 almost, which is an effective value of this. And now putting the value of z equal to 1.69 into this. So it will make our H equals, it will make our H equal minus 2 and 1.69 squared plus 27 over 4 into 1.69. This implies that H, the Hamiltonian, comes out to be minus 77.5 electron volts. Okay, I have forgotten E1 here. So E1 is here, which is 13.6 electron volt. So putting E1 there, and thus we get this is minus 77.5 electron volt, and this I have told you earlier that we will reach closer to the ground state value, and this is just 1.5, approximately 1.5 electron volt less than the actual experimental value. So by incorporating only z, minimizing this z, we reached a value much closer to the experimental value. So if we do include the fine structure, the hyperfine structure, then basically we will be very close to this one, and the trial function minimization or optimization, this will make us to reach the actual value, which is the experimental value. But based on the level of this course, we will stop here on this value of H. We are happy, and we will proceed toward the next topic in this, which is the last topic of this chapter, the variational principle, and we will have to consider the hydrogen molecule ion, and that will give us a lot of additional details, then how bonding occurs, and we will discuss that thing from the point of view of quantum mechanics.